There we are. We are on chapter 7, and we're still continuing with chapter 7. Possibly today we might finish it. And remember, our classes are going to cease very soon. So let me just quickly go to the window journal so that we can share this together. Just a bit while I'm still going there. There we are. I think it's lecture number 23. It's lecture 23. And still about cluster sampling. Okay. Cluster sampling. So far, we have covered how to estimate the population mean, how to estimate the population total, and how to estimate the variance of the estimated population mean and the variance of the estimated population total. So far, I hope you know how to estimate those. So far, we have covered that. So today, we are going to continue with the cluster random sampling. And in this case, we're going to show you how to select the sample size for the estimation of population means and population total. Okay. Then I have to show you how to estimate the population proportion and how to select the sample size of the population proportion. So those are the things that I think today we're going to cover them. Then later, I'm going to give you a theory. Then later, we're going to do the examples. So let's quickly go there. Like I said, is the selection or selecting the sample size for estimating the population mean, or let's say means and totals. Okay, so in other words, what we're trying to do here, I'm going to show you a formula that you can use to select the sample size required to estimate the population mean. Okay. Then later, I show you the formula that you can use to select the sample size for estimating the population total. Okay. So now let's start with this one. How do you select the population? How do you select the sample size for estimating the population mean? So in other words, we're saying sample size required to estimate the population mean. Sample size required to estimate the population mean. Sorry, this is the mu. So that's the mu. So we use sample size n, which is equivalent to n times sigma squared r. Okay, then you divide everything by capital letter M times a d plus sigma squared r, where in this case sigma squared r, you know that this one is a what? It's a population variance, isn't it? So this is the population variance. Under cluster random sampling. And this population variance can be estimated by what? SR squared, isn't it? That's the sample size under cluster random sampling. So now SR squared is equal to what? If you know, summation of yi minus rmi. Okay, then you do what? You square it, then you divide it by n minus 1. And remember, I is ranging from 1 up to n. Okay, sorry for that. So our sigma squared r is the population variance and is estimated by SR squared, which is the sample variance, which is equal to what? Summation of yi minus rmi divided by n minus 1. And d, and that capital letter D is equivalent to what? B squared times capital letter M bar squared, all divided by 4. That's our D. And as you know, B stands for what? Is the bound on the error of estimation, isn't it? The error of estimation. The bound on the error of estimation. What about M? Capital letter M, still recall, is the number of elements in the population. That is the number of elements in a population. Okay. What about N? Capital letter N is the number of clusters in a population. This is the number of clusters in a population. So this is how you estimate, select the sample size required to estimate the population mean. It's equal to n times the population variance divided by n times t plus the population variance, where that population variance is estimated as what? It's a sample size, a sample variance, which is given by the summation of what? Yi minus rmi all squared divided by n minus 1. And d is equal to b squared times capital letter M bar squared over 4, where B is a bound on the error of estimation, and then capital letter M is the number of elements in a population, and capital letter N is the number of clusters in a population. Are we together? So now, how do you select the sample size required to estimate the population total now? So because we've already done with the sample size required to estimate the population mean, let's continue to the sample size required to estimate the population total. Okay, let me just scroll a bit, or I can just write it here using a different color. This sample size required to estimate the population total, that is tau. Okay, so we use the same formula up there. See that formula? We use the same formula, this one. This is the same formula that we're going to use. The only different would be on the what? On the D. Okay. So in other words, what we're saying is we use N, which is equal to capital letter N times sigma R squared. Then you divide everything by what? By N times D plus sigma squared R. So this is the same formula. However, our D will be equal to V squared over 4 times N squared. Okay, so where B is a bound on the error of estimation, and capital letter N is the number of clusters in the same population. Are we together? So far you know how to select the sample size required to estimate the mean and the total. Any question before we go to the example? Any questions so far? None. But are you still there? Because sometimes I will be talking alone. Are you there? Can anyone respond, please, to show that you are with me?
Yes.
Yes, sir.
Okay, thank you very much. So I'm confident to go forward. Okay, so now we are done with our theory. Let's quickly go to the example on how can we apply that. How can we apply those two formulas? The formulas for selecting the sample size required to estimate the population mean and the population total. So for those who are having the lecture notes, may you please open on page which page is this? Page 60. Page 60. Let me just write it down. So it's example. And it's example 7.5 on our lecture notes. Okay. And it's page 60. Okay. Remember, it's a continuation of example 7.2, if you still recall, because here it refers us to table 7.2, and table 7.2 is from example 7.2 on page 58. It says, let me just read a little bit so that you can follow. It says, suppose the data in table 7.2, data on page 58, represent a preliminary sample of incomes in the city. Full stop. How large a sample should be taken in a future survey in order to estimate the average? Okay, we just want to find the sample size in order to estimate the average income, which is the mean, with a bound of $500 on the error of estimation. In other words, in this case, we have been given some information there. The first one is a what? It's a bound, isn't it? Of $500. Just say 500. Okay. That's the given information we have. And remember, this is the continuation of example 7.2 on page 58. So we have the information on that example. So we can just try to use them. Like, for example, the number of clusters in the population, which is the capital letter N. It was given to be what? Those who were with me before, what was our population size on example 7.2 on page 58? The number of clusters in the population is what?
415.
415. Thank you very much. It's 415. That is another information that they are required. So another question is, remember, there are some instances when M is given, and there are some instances where M is not given. Remember, M is the number of elements in the population. So in that case, example 7.2 on page 58, was M given or not? In that case, it was given, isn't it? Because there was a number of blocks there. Number of blocks, so it's the same as the number of clusters in the what? In the population, which is what? Capital letter N. So in that case, our M was not given. Is that true?
Yes.
For those who were with me, okay, it was not given. In other words, M is unknown. And I said, if M is unknown, what do? We estimate our M bar, isn't it? As what? A small letter M bar, which is equal to what?
Summation of M over N.
Yeah, thank you. Summation of Mi over N, which is equal to what? What is the summation of Mi over N from that table? What is the summation of Mi?
151.
And N is what?
25.
It's 25. And the value is what? The value is what?
2506.6.
What?
2506.
250.
Oh,
Are you sure?
6.05.
6.04.
6.04.
Thank you very much. Now, you see this value 6.04. If you go back to that table there, on page 59, summary of basic statistics for the data presented on table 7.3. You see that table, the summarized one? There is a resident income and all those stuff. So those are information that we are going to use going forward. So, but anyway, our M bar is 6.04 because M is unknown. So that is why we have been forced to estimate capital letter M bar, which is equal to the small M bar, which is equal to summation of Mi over N. And at the end, we ended up getting 6.04. Okay. So now we have got the number of clusters in the population, we've got the bound on the error of the estimation, and we've got our M bar or M. Yeah, M bar. So now we can use that information. Remember, we just want to select the sample size required to estimate the what? The population mean, isn't it? Just quickly go to that example and write the question down so that you can follow. How large a sample should be taken in a future survey in order to estimate the average the population mean, isn't it? With a bound on there. So in other words, we use the same formula, N, which is equal to capital letter N. And remember, in this case, what is our sample variance? In other words, you have to find S, because we don't have it, SR squared. And my SR squared is equal to what? The summation, okay, of YI RMI all squared divided by what? N minus 1. And what is the value of that? You can tell me the value there. Remember, we're still using that table, 7.2.
25189.
Yes, it's 25189. Two 5189 squared, isn't it?
Yes.
Okay, now let's go back to our formula now and try to plug everything. So it's SR squared. So you can just use sigma squared R, it's the same thing, because at the end of the day, you're going to substitute with the what? The estimated one. There's no harm on that. N times D. Our D is going to be what? B squared, M bar squared over what? Over 4, isn't it? That is our D. Then plus SR squared. Then capital letter N is 415. And then the sample variance is 2519. 189, sorry. Two 5189 square. Okay. Then you divide everything by 415. You multiply it by a bound. A bound is 500 there. M bar squared. So 6,04. Then you square it. Then you divide it by 4. Then you add what? 25189 square. Think. Oh, bound is squared as well. I think everything is correct there. Please check. And then please give me the final answer there.
Three three two, 822.
332.
2 A,
Okay.
822.
Point
822.
822 like this.
Yes.
Is that true? Everybody get it right like that? Is there anyone saving a different answer?
So I'm getting 166.
166.
0.57.
166 point. What? 5?
576.
576. What is the correct answer now? Correct answer? Guys, are you calculating or you just want to copy? I want to know which one is correct between the two.
Someone says
Is this one?
167.
Is this one?
Yeah.
So a lady,
So,
please check your answer. Check this one. Your calculation, I think, is wrong. I think this one is the correct one. Even myself, I get it this one. So just go and check that one. Or if you don't understand, please ask. Or maybe share with us what. Or are you using the same substitution there?
Yeah, I used the same substitution, just that I did a mistake. I didn't square the 6,04.
Oh, okay, it's fine. But now you got the same answer, 166, isn't it?
Yes.
Okay, thank you. Let me just erase this one so that you won't get confused. So the answer is 166.576. Remember, it's a sample size. Can take it to be a whole number. So the final one is what?
$167.
167. So that's it. I think it's clear for everyone. So can we go to another example again, which is example 7.6. Example 7.6 on the same page. It's page 60. Okay. Again, it refers us to the same table. It says, using the data in table 7.2 as preliminary sample of incomes in the city, how large a sample is necessary to estimate the total income of all residents, that is the town, with a bound on the error of estimation of $1 million. And they said there are 2,500 residents. So in this case, let's try to write down the given information. Let's start with the bound. Bound says it's $1 million. So 1000000. That's a bound. The question is M given or not? Is M given or not? Is there any number of elements in the population?
$2,500.
Yes, thank you very much. Now here in this case, M is given. It's given as 2,500. Okay. And remember, we are still having the same number of clusters in the population, which is capital letter N, and is equal to 415. Okay. There's another information. And the sample variance SR squared, which is equal to the summation of I RMI all squared divided by N minus 1. It's equal to what? It's the same thing, isn't it? 25 what? 1 yeah, 25189. Still the same thing. 9. Then you square it. Okay. Another given information is what? I think that's it. Okay, so now let's use a formula now to select the sample size required to estimate the what? This time around is the population total. So our N will be equal to N times sample variance divided by N times D, and our D in this case goes for estimating the what? The population total is B squared over 4 N squared, isn't it? Yeah, this is the one. Okay. So this is the formula, then plus sample variance. So the number of clusters is 415. And the sample variance again is 25189. Then you square it. Then you divide it by again the number of classes 415. Then a bound of a million. Then you square it. Then you divide it by what? By 4 times 415. Then you add what? Simple variance 25189. Then you square it. So this is sorry. Can you please find the answer for us? Can you find the answer for us? M is known, so that is the formula that we have to use. Substitute, then give me the final answer.
Sir, Liveji squared more n.
Come again?
Liveji squared more n. Come first.
Oh yeah. Okay, thank you.
Two and two.
212 point 212 point what?
88.
So which is equivalent to what? 213. So this is our sample size required to estimate the population mean. Now, I have a question for you. On the same example, I want you to select the sample size required to estimate the population total when M is unknown. Are you still going to get the same answer? Let's say in this case, M is unknown. Find N. Sample size required to estimate the population total. The population total. Remember, we're estimating what? The total income of residents. Okay.
Sir,
You want to find the sample size, eh?
I want to ask something. When M is unknown, we estimate M and we include the M on the bound.
If M is there, you don't include it on the bound. It's here. Let me just go. Here we don't have M here, as you see. Here, there's no M. But when you go up there, I want to show you where M is. Where is it? Maybe I skipped. For the mean. See where M is. It's here. It's where M is. So that means if M is not given, we are going to estimate it using M bar, like what we did here, and find it that way. So it's not like M is on the bound. It's not on the bound. It just D is equal to B squared M bar squared over 4. When you are selecting the sample size required to estimate what? The population mean. Okay. But if you want to estimate the population total, your D is going to be B squared over 4N squared. So you see now, there's no M here. But still, you can find that in the given information, M is not given. So what do you do if M is not given and you want to estimate the sample size required? You want to select the sample size required to estimate the population total. So my question is, are we still going to get the same answer or not? And remember, according to that example 7, there is somebody who didn't meet the mic there.
Smanga.
You can hear the echo. So according to example 7.6 there, if you can listen very carefully, it says, using the data in, is it this one? Yes, using the data in table 7.2 as a preliminary sample of income in the city, how large a sample is necessary to estimate the total income of all the residents, that is town. And remember, here we were given the what? The M. M was known, which is 2,500. And we just want to estimate the sample size, to select the sample size required to estimate the population total. This is what we did. So the question is, if M in this case is not given, and we want to select the sample size required to estimate the total income of all residents, are we still going to get the same answer or not? That's the question.
Sir,
Yes.
I think we're still going to get the same answer because when estimating the sample size, we are not using M.
Okay. Anyone who's having the different idea, or all of you agree with him?
Yes, we agree.
No, it's not true. We won't get the same answer, in the sense that even here, if M is not given, and remember we have been controlled by the sample variance, this one. If M is given, the sample variance is supposed to be this one, according to that statement here, even if we are estimating the total income of all residents. So if M is given, so this is our sample variance. But if M is not given, let's go back to the data, to the table that they are talking about, page 59 down there. If you check page 59 down there, the summary, table 7.3, you see that one. There is a residence, there is an income, there is yi minus y bar mi. Because m was given there, at the end of the day, to calculate the sample variance, we ended up taking SR squared to be equal to 25189. Because the last one there, and square it, we use this one because M it was given, even though we are estimating all the income of all the residents. So that is the sample variance that we're using. But in this case, we're estimating the income when M is not given. So that means you have to take the standard deviation of the income there and you square it. And the standard deviation of the income there is 21784. Then you square it. This is when M is unknown. Yes, let me just write this one. I'm going to listen to. So this one is when M is known. Actually, it's a capital letter M. Okay. Give you the chance.
So
yes, now you can.
So why on the previous example 7.5 M is unknown, but we used 25189?
Okay, let's go to that example. 7.5 example to guide us. Suppose the data in table 7.2 represent the preliminary sample of income in the city. How large the sample should be taken in future surveys in order to estimate the average per capita income new with a bound of 500 on the error of estimation. How large the sample size should be taken to estimate the average income. Okay, let me see the table then. Well, in this case, M is not given, and we ended up using 251. And even in this case, it's about the income. I think you can just go on. Or maybe in this case, just because we ended up estimating it there. We ended up estimating there, and then we just take it as it is there because now we have already estimated. At the end of the day, we ended up getting M bar. But in this case, for M, for the total, we don't have M at all. So we don't have to estimate anything. So in this case, if M is not given, so we don't have to use the sample size, the sample variance, which is this one up there. So we use the sample size, sample variance of the income, because we don't have M at all. We don't have M at all. So in that case, we ended up estimating it. But here we just use the total and without estimating anything. So at the end of the day, we don't have M at all. But here we use this one because M is unknown and we didn't even estimate it. I don't know whether it's clear whatever I'm explaining there.
So what if we estimate it again?
And do what? Because we don't want to use it. And you estimate it and you use what?
Okay. Okay, sir.
Okay. Any question? So can we go to the proportion, and then I think this is the final topic of the final of our chapter. I think so. Yeah, I think it's the final topic of our chapter. It's page on page what? Page 61. It's population proportion. So we're going to talk about how to estimate the population proportion, how to estimate the variance, and how to select the sample size of that estimator. Then that's it. I think we'll be done for today, and we'll be done for the module. I think so. Immediately when we are done with that. Okay, let's quickly go there. Estimation of population proportion. So when you estimate the population proportion under cluster random sampling, we use p-hat. Okay, this is the population proportion, the estimated one, which is equivalent to the summation of what? AI. Okay. Then you divide it by, or I is ranging from 1 up to n, divided by summation of mi. I equal to 1 up to n. Where in this case, AI is the total number of elements in cluster. Number of elements in a cluster. Sorry. Number of elements in a cluster. Okay. AI is the total number of elements in cluster I. And then if you want to estimate the variance of that estimator, in other words, estimated variance of that estimator, which is p-hat, is given by what? By var estimate of p-hat, which is equivalent to what? To n minus n. Let me just write it nicely here. Estimated var of p-hat n minus n divided by n times small letter n bar squared. Okay, so we can just write it in this way so that it can make sense. SP squared over n. Yes. N minus n divided by n times capital letter M bar squared multiplied by SP squared over n, where in this case SP squared is the sample variance of the proportion, where SP squared simple variance for the proportion, which is defined by what? AI minus P at MI, then it's squared. Then you divide it by what? By n minus 1. So this is the sample variance under population proportion. It's given by summation of ai minus p at mi all squared divided by n minus 1. So again, if you want to select the sample size required to estimate the population proportion under cluster random sampling, you have to use this formula. Let's say the sample size required to estimate the population proportion, okay, is given by n equal to n sigma squared p squared actually it's the same thing as n times d sigma a plus sigma squared p, which is the same as n as p squared, isn't it? N times d plus as p squared, where in this case our d is equal to what? B squared m bar squared over 4. M bar squared over 4. I think those are the formulas that I wanted to introduce it to you. Any question? Okay. So now let's quickly go to the examples now. Example 7.7. Example 7.7. It's on page 61. Okay. Just write it down. Example 7.7. I think it's on page 61. Okay. Okay. Are you there? Okay, let me just try to read it a bit so that you can have an idea if you don't have it. For those who are having it, please open page 61. It's example 7.7. It says the residents of the sample survey are asked whether they rent or own their homes. The results are given in table 7.4 below there. It says use the data in table 7.4 where n. So that means the number of cluster in the population is given. Still the same, 415. Okay. Where n is the number of clusters in the population, to estimate the population of residents who lived in rented housing and place a bound. In other words, here we just want to estimate the population proportion of the residents who lived in the rented house. In other words, we just want to find P. And then later they said place a bound, and then we find B. As you know, B is equal to what? 2 times the square root of the estimated value of P8. So you have to estimate the population proportion, then later you estimate the variance of that estimator, and then you conclude by finding the what? The bound. There are 3 things that you have to do. So table on table 7.4 on page 61, they gave you the residents and renters. Residents is MI and renters is AI. Then from there, they ended up summarizing everything for you. And they also find the summation of MI and summation of AI. But you know how to find the P8, isn't it? It's the summation of MI of AI, sorry, over summation of MI. Okay. So the summation of AI is what? They did that for you. They have already calculated everything for you. What is the summation of AI?
2.
72. Then you divide by summation of MI.
151.
151. Okay. Then the answer is what?
0.477.
0.47. So 77. Okay. Yeah. So that's it. Then you have to find what the estimated variance of that estimator. Okay. Which is given by n minus n over n times m bar squared. Then multiply by sp squared over n. And our sp is what? Which is summation of ai minus p at mi squared divided by n minus 1. So our sp squared, or simple variance for the proportion, is what?
0.726 squared.
0.726. Then you squared it. Okay. So we have it. What about our m? It's not given, isn't it? You have to estimate it. What is the answer? So it's going to be m bar mi over n. And the answer is what? Anyone? Are you still there?
6.04.
Yeah, 6.04. Okay. So we have all the informations now. So we can just plug everything. So this is equal to 415 minus sample size is what? 25, ne? Yes, 25. Don't have a space now. It's 415 minus 25 divided by 415 multiplied by m bar squared. So it's what? 6,04, then it's squared. Okay. Then you multiply everything by SP, which is what? 0,726 squared. Then you divide it by sample size, which is 25. Then give me the answer.
5,43 times.
So what? Come again? I didn't get it. Can you please repeat?
Sir, sir,
Yes, I'm listening.
is 0, comma,
Mm.
0001.
Double zeros.
Well, let me give you okay, the first 5 digits is 0,
Mm.
comma 000, another 0,
Okay. Yes.
54.
54. That's true. Then what about the bar?
We'll get 0, comma 0466.
0,04 double six.
66. Yes.
Okay, thank you. I think that's the answer now. So may you please do example 7.8. I think it's the last one. It's the last example. Then we'll call it a day. It's example 7.8. It's on page 16. Again, we are going to refer to table 7.4. So they say a new study will be conducted in the same city for the purpose of estimating the population proportion of residents who rent their homes. How large a sample should be taken to estimate the population proportion with a bound on the error of estimation? So in this case, we just want to find what? The sample size required to estimate the population. That's n, and n is equal to what? Capital letter N times SP squared, then divided by n times the bound m bar squared over 4, then plus SP squared. I think you have all the information there like we did on the previous example. So it's the matter of just plugging everything and then you get the result. Population size is 415. And then a sample variance under population proportion 0,726, isn't it? Then you square it, then you divide it by 415. Okay, let me just do it this one. I'm saying it's 415 multiplied by 0.726 squared divided by 415 again. Bound is what? 0.04. 0.04. Then you square it. You multiply it by what? Or square it and then you divide. Or you multiply by m bar, which is what? 6.04. Again, you square it and then divide it by 4. Say plus sample variance 0.726. You square it. What is the answer? I think we did everything correct. Yes, I think we plugged everything. So, what is the answer?
Thirty-three comma 227.
What? Come again?
33,227.
33.22.
7.
7. Okay. Why are you whispering? Which is equal to what?
34.
34. That's it. I think this concludes our lecture, and this concludes our syllabus. So we are done. Any question? Any question about what we've done so far? If none, let me just say thank you very much for everything. For the good behavior you gave me. It was wonderful. So next week, I think it's our final week before you go and start preparing yourself for the exams, or before the classes is. We were going to. I'm going to give you a feedback. I think on test 1, test 2, and quiz 3, if I'm not mistaken. And then I suppose that by that time I would have given you all your assessments, all your results, so that you can check. If there are any mistakes, then you report before it's too late. And let me just remind you that the weight of a sample theory module, how to calculate your weights, you're going to take the average quizzes, okay? Then you multiply by average quizzes is 10% of that. Take the 10% of quizzes, and then you take 20%, sorry, and 10% for the assignment, and 70% is for the test. In other words, when you want to calculate your module, you take the average of the quizzes, quiz 1 plus quiz 2, then you multiply by 0.2, sorry, and then you said plus assignment, which is what? Take your assignment because it's 1, then you multiply by 0.1, then you said plus, you take the average of tests, then you multiply by 0.7. It's going to give you your module mark. And to qualify, you are supposed to have 40 and above. To qualify for the exam, supposed to have 40 and above. So far, there are those who have already qualified before I include the assignment. So, but there are those who are not yet. but when I include the assignment, I think they're going to qualify, as long as you have done well in that assignment. And the due date of the assignment is next week, Monday, before, let's say 4 o'clock. I think I indicated there. So for tomorrow, it will depend, because Mr. Maluleke said that he will ask my class. He just want to use my class. So if he take my class, so we want to have a class tomorrow. But if he don't take it, so we are going to have it. But we shall communicate. If we don't have any class, we are going to communicate. I'm going to communicate with the class reps if we're going to have a class or not. Any question? So I can switch off the camera, the recording.